All right, let's talk about the computer. You've got one in your pocket, on your desk. They're everywhere. But where did they really come from? Well, the story doesn't start with silicon and circuit boards. Nope. It starts with something way more surprising. The first computers, they were people.
Seriously, check out this quote from 1613. That's not a typo. Back then, the word computer literally meant a person. It was a job title. Your job was to, well, compute, to do calculations by hand all day long. Can you even imagine?
And right there, you see the first big problem we had to solve. Because let's be honest, doing math by hand all day, it's slow, it's boring, and most importantly, people make mistakes. And when you're talking about things like navigating a ship across the ocean or figuring out where a cannonball is going to land, a tiny little error can be, well, catastrophic. We absolutely had to find a better way.
So that sparked this big, audacious idea. What if? What if we could build a machine that did the calculating for us? Something that wouldn't get tired, wouldn't get bored, and most importantly, wouldn't make those simple human errors. And that quest right there is the first giant leap forward.
And you know what's wild? The blueprint for a modern computer was actually drawn up way back in the 1830s. This guy, Charles Babbage, came up with something called the analytical engine. And get this, it had an input, a processor he called the mill, and memory he called the store. I mean, that's basically a CPU and RAM. It was brilliant. But there was a huge catch. It was a century ahead of its time. The technology to actually build it with all its thousands of tiny, perfect gears just didn't exist. So Babbage figured out the how in theory, but that just created an even bigger problem. How on earth do you actually build the thing?
And the answer to that engineering problem? It wasn't better gears. It was to throw out the gears completely and jump to something totally new, electronics. And let me tell you, this is where our story kicks into high gear.
Okay, so first we had these things called electromechanical relays. You can think of them as these little physical switches just clicking open and closed. Faster than a person, sure, but still pretty clunky. Then came the big one, vacuum tubes. The famous ENIAC computer used something like 18,000 of them. This thing was an absolute monster. It weighed 30 tons, took up an entire room, and got incredibly hot. It was a huge step, but let's be real, it was completely impractical for anything other than a giant lab. But the next couple of steps on this timeline, they were about to change the world.
And then, in 1947, boom, the transistor is invented. And this wasn't just an improvement, it was a revolution, a total game changer. Everything that was wrong with the vacuum tube, it was big, it was hot, it used a ton of power, it broke all the time, the transistor just fixed it. It was tiny, it ran cool, it was efficient, and it was super reliable. It literally solved every single one of those problems in one go.
And that one invention kicked off this incredible shrinking revolution. So first, you had transistors just replacing the old clunky vacuum tubes one for one. But then came the real magic, the integrated circuit. The idea that we could etch thousands and then millions of these tiny transistors onto one little sliver of silicone. All of a sudden, the computing power of that 30-ton room-sized ENIAC could fit in your hand. And that, right there, is what made computers small enough, cheap enough, and powerful enough for the rest of us.
Okay, so problem solved, right? We've got these incredible, powerful little machines. But wait, solving one problem just revealed a brand new one. You have all these amazing electronic brains, but they're all alone. They're like little islands of information that can't talk to each other. So what good is a powerful brain if it's completely isolated?
The obvious solution, of course, was to connect them. And that's exactly what happened. Back in the 1970s, a project called ARPANET started figuring out how to get these different computers in different labs to talk to each other and share data. And that little project? Well, that was the seed that eventually blossomed into the internet.
And that simple idea of just connecting a few machines has just exploded. We now have this entire ecosystem of networks all built for different jobs and different sizes. We're talking everything from the stuff you've got on your desk right now, all the way up to a network that covers the entire globe.
So let's break that down real quick. The smallest one is a PAN, a personal area network. Super simple, that's just you connecting your phone to your Bluetooth headphones. Easy. Then you've got a LAN, a local area network. That's your Wi-Fi at home or in the office. A little bigger, you have a MAN, a metropolitan area network, which could connect, say, all the buildings of a university campus across a city. And then there's the big one, the WAN, the wide area network. These cover huge distances, and the ultimate example of a WAN is the internet itself. And when you look at it like this, the jump in scale is just staggering. We basically live inside this giant, nested doll of networks, your personal one, inside your local one, inside a global one. And it's this whole architecture that keeps our entire world connected.
So you see the pattern here, right? The entire history of the computer is this amazing chain reaction. You solve one problem, and that solution creates the next challenge. The problem of human error, we solved it with mechanical machines. The problem of those machines being too slow and complex, we solved it with electronics. The problem of all those computers being isolated, we solved it with networks.
And that brings us right here to today. We've solved for calculation, we've solved for speed and size, we've solved for connection. But now, with the explosion of artificial general intelligence, it feels like we're standing at the edge of the next big problem. And maybe this time, the challenge isn't about the hardware or the software. Maybe the next big problem to solve is our relationship to these incredibly intelligent machines we've created. So, what do you think? What's the next chapter in this incredible story?